So for the rest of the class, we're going to do a running example to kind of flesh out the ideas of factorial design. So the goal here is to help you understand main effects, interactions, bar graphs, and line graphs. So for our running example, we have two independent variables. The first is the time of day, either students taking a class at 9 in the morning or 3 in the afternoon. And then the other independent variable is where they're assigned to sit. They're either randomly assigned to sit in the front or in the back. And the dependent variable is grades in the class. Now, to make sure you understand main effects and interactions, there are as many possible main effects as there are independent variables. So, there's a possible main effect for seating location. And this is very important. A main effect of seating location is potentially telling you that there's a difference, a significant difference between students in the front and students in the back. It doesn't say which one is doing better on the class. It's saying that there's a significant difference between students in the front and students in the back. And we're talking about a main effect of seating location. We do not factor in time of day. All we care about is, are the students sitting in the front or are they sitting in the back? Independent of what time of day it is. Time does not exist in this main effect. All that exists is whether students were in the front or in the back. There's also a possible main effect of time of day. If you have a main effect of time of day, it says that there's a significant difference between students in the 9 o'clock class and students in the 3 o'clock class. Again, it doesn't specify which one is doing better. It's saying there's a difference. Now, the line graph or the bar graph will help you figure that out, but a main effect in and of itself just says that there's a difference between your two groups on that particular independent variable. And again, this is crucial. A main effect of time of day does not factor in where students are sitting. Where they sit is irrelevant. All we care about is whether students are in the 9 o'clock class or the 3 o'clock class. So what we're going to do is we're going to take the students in 9 o'clock, both front and back, average them, and compare it to the average of students in the 3 o'clock class, front and back. But again, we don't care about front and back. All we really care about is if students are in the 3 o'clock class or the 9 o'clock class. So for this particular design, which is the 2x2 design, we have a possible main effect of seating location, a possible main effect of time of day. So we have two possible main effects. We have one possible interaction between our two independent variables. It's important to understand the interaction is between your independent variables. We have two independent variables, seating location, time of day. The interaction is between those two independent variables. If we have a significant interaction between those independent variables, it says that the effect of seating location depends on whether students were in the 3 o'clock class or the 9 o'clock class. All right, so what I'm going to do for this running example, I'm going to give you 8 different hypotheses. And what I want you to try to do is to try to make sense of these hypotheses. Ideally, what I want you to do is I want you to try to draw a bar graph and a line graph representing those hypotheses. So this first one is that there's no main effects and there's no interaction between any of these variables. So if you're thinking about the null hypothesis, it's basically saying that what we're hypothesizing essentially is a null hypothesis, that there's no differences between any of our groups, that they're all the same. So if we were to draw a line graph, it's a little bit hard to tell, but what we have here is all the endpoints of the lines are the same. So the line representing the front, which is in red, is the exact same as the line representing the back, which is in blue. So they're all on top of each other. So when there's no main effects, no interactions, it's simply saying that all the conditions are exactly the same. There are no significant differences between any of our conditions. And again, for a line graph, all you're really doing is you're drawing the endpoints and then you're connecting them with the line. The line does not really mean anything. It just helps you visualize the pattern of the results. It's the endpoints that really matter, not the line itself. So if you had a bar graph, it would essentially look like where all the bars are exactly the same, because again, they don't significantly differ from each other, so all of the four bars are the same. Now, one important thing to remember when you're drawing a line graph or a bar graph, your graph has to represent all four conditions. It's a 2 by 2, so each condition needs to be represented in the graph. Okay? You can't leave one out. All four have to be uh, represented in all of the different graphs, either a bar graph or a line graph. Okay, so our second hypothesis, we're arguing it's going to be a main effect of time of day. And for this particular hypothesis, we're going to be very specific because, again, there's two potential ways you can have a main effect of time of day. You could have the 9 o'clock class do better than the 3 o'clock class, or the 3 o'clock class does better than the 9 o'clock class. We're hypothesizing the first one here. So I hypothesize that there will be a main effect for time of day such that students who are in the 9 a.m. class will have higher grades than students in the 3 p.m. class. So the key here is to recognize this specific prediction. Students at 9 o'clock on average, so we're going to average the fronts and the backs at 9 o'clock and compare it to the average of those in the 3 o'clock. And the hypothesis is that those at 9 o'clock will do better than those at 3 o'clock. Now, we're not predicting any main effect of seating location. We're not predicting an interaction between the two. All we're predicting is the main effect of time of day, and we're focusing on the first one, not the second one. So I'm going to show you the graph, and then the next one I want you to pause the video after I give you the hypothesis and try to graph it yourself. So if you have a line graph, it should look like this. Because again, it's saying that the participants, the students in the 9 o'clock class, on average, are going to do better than the students in the 3 o'clock class. And because there's no other main effect and there's no interaction, we're going to basically put both of the 9 o'clocks at the same point. So they're both here at about 90%. And the students at 3 o'clock, we're going to put them both at this point here, which is, I guess, about 65%. And we just draw lines connecting them. So this line graph will represent when we have a main effective time of day such that students at 9 o'clock do better than students at 3 o'clock, but it also indicates that there's no main effective seating location and there's no interaction between time of day and seating location. Now, if we were to convert this to a bar graph, the bars for 9 o'clock will be the same, so they're both going to be at 90, just like the line graph, both of the endpoints were at 90. And then for at 3 o'clock, both of the bars are going to be at 65. So again, this tells you that there's a main effective time of day, such that on average, the 9 o'clock class did better than the 3 o'clock class. There's no main effective seating location, and there's no interaction between the two. All right, so let's try another one. And this one I want you to see if you can do it yourself. So we're hypothesizing a main effective seating location such that students in the front will have higher grades than students in the back. Importantly, we're not hypothesizing a main effect of time of day or an interaction, only a main effective seating location. So we're saying the average of those in the front will be higher than the average of those in the back. And we're focusing on this first one. We could have argued the opposite, but we're just focusing on this first one for right now. So if you hopefully graphed it out, this is what you would get. The average of those in the front, right? And again, I didn't give you any numbers, but just I want you to look at the pattern here. Those in the front are doing better than those in the back. And because we don't have a main effect of time of day or an interaction, you just put the two fronts as being the same and the two backs as being the same. And again, because I didn't give you the numbers, you could have put the fronts and the backs higher or lower, but you just want to indicate that there's a difference between the average of the fronts and the average of the backs. So I could have put the backs lower and they were both at, let's say, 30%. That would indicate the exact same thing. The numbers essentially are arbitrary, but it's the pattern that I want you to understand. So the pattern is there's a main effective seating location such that the average of those in the front is higher than the average of those in the back. There isn't a main effect of time of day, and there isn't an interaction. If we had a bar graph, again, the bars for our fronts would be the same, and the bars for our backs would be the same, just lower. And again, we could have lowered both of the backs, and it would have still said the exact same thing. Again, we're looking at the pattern, not necessarily the actual means for the group.